Okay, here we are again, and we've got the same question. I'm going to do method 2. And always start with your normals, but we've already done the work with the normals, so we know normal 1 is equal to negative 1 normal 2, which means that the planes are parallel. If you're confused on that, go back and watch the video just before this one, and we went through that argument in detail. So what we really need to know now is whether or not they share a point. Now, we did it using 1 point and parametrics in the last one. I wonder if there's another way to do it. Yes. Why don't we take a look at the scalar equations? Why don't we take the normal for the first one? Now, we never did figure out what it actually was. Remember, I'm reducing this because it's just the direction. So it's negative 1, 5, 2, negative 1, 5, 2, 1, 2, 1, 1, 2, 1, goodbye, goodbye, down products, 5 subtract 4 is 1, 2 plus 1 is 3, negative 2 subtract 5 is negative 7. Looking to the audience. Okay, that's my normal. With that information, I know that the scalar equation of this puppy can be found by using ax plus by plus cz plus d equals 0. I can plug in 1 for a. I can plug in 3 for b. I can plug in negative 7 for c. And that leaves d unknown. But we have a point on the plane, so we can sub in point. And that will allow us to determine d. And so the point that I'm plugging in is 0, 3, 2. So we put in 0 for x, we put in 3 for y, we put in 2 for z, and that means that it's going to be 9 minus 14. Is that 5? So it's negative 5, but it goes over to the other side, so it'll be positive 5. So the scalar equation of this is x plus 3y minus 7z plus d. Thank you. Tell me earlier. Equals 0. Sorry, guys. I'll pause here for a moment so that you can see all of it. Maybe I'll back out a little bit. Let's see what happens. There we go. That might... Let's see if this keeps me on this page a little bit more. So once again, we came up with the scalar equation by using the normal. We then took a point that was given to us on the plane. We plugged it in. We calculated d, and we have the scalar equation of the first... We have the scalar equation of the first plane. Now, that's neat, because I'm going to use that scalar equation. Let me rewrite it so I have another page to work with. We already know that... Oh, why did I do 5? Guys, audience, what are you doing to me? They're going to lose their take-home gifts. Okay, so we have that for the first plane. We already know that they're parallel, so the question is whether or not they share a point. So why not take this point and plug it into this equation and see if it works? See if point negative 2, 6, 3 lies on both planes. We know it lies on this one because I used it. So let's plug it in. Negative 2, 6. So this is really an assumption, right? Assume it does. Therefore, it should satisfy this. Let's see if it does. Negative 2 plus 18 minus 21 plus 5. Ew. Okay, that's going to be 3. So 3 plus 18 is 21. Guess what, kids? Therefore, the point lies on both planes. The planes are parallel. They share at least one point. Therefore, they share every point. Therefore, they're the same plane. We're done. You can write the rest in on your own. That was method 2. Well, let's do method 3, but that'll be in just a moment, and we'll come right back.